Why is there light on Earth? Not in space. And what you see now, it's the real starry sky photographed by the space station. There's no atmospheric disturbance. Even nebulae are clearly visible. But here's the problem. Space where nothing blocks the sun should be brighter. But why except for the faint starlight? Only endless darkness remains, and the Earth is brightly lit. You might say, and that's not easy. The Earth goes around. Where does the sun shine? Which side is daylight? What you don't see is night. You're half right, but the truth is more complicated than that. Think about it. Doesn't the sun also shine on the moon? Why is the sky above the moon always dark? Secret. All in Earth's unique atmosphere. In the atmosphere, there's dust and particles of gas and water. These things are like a billion little mirrors. It reflects sunlight away. As soon as the sun hits, these little particles will spread out into various colors. This is why we can see blue skies and those beautiful rays at sunrise and sunset. But somewhere else, it's the other way around. If you stand on the moon, because there's no atmosphere at all, the sky will always be as black as ink. Even the moon during the day, the sun scorched the surface. You can still see the sky full of stars when you look up. Space is the same. There is a lot of gas in space, but no atmospheric molecules that reflect light, and frankly, space is an empty shell. Near vacuum. No matter how bright the sun is, space still looks like a pitch-black void. What if one day the Earth's atmosphere is gone? It's going to be as dark as the moon. That's why our planet is so bright. It all depends on the reflection plate of light in the atmosphere. This problem is solved, but here comes another problem. There's more than just light in the universe. The sun. Then why are other stars? You can't make night look like day. You're not the first person to think about this. As early as the 16th century, astronomer Thomas Digges studied this question. He thought the universe was boundless. There are countless stars. He tried to explain why so many stars couldn't blind us. It didn't work. It's not that he is not capable enough. The problem is too advanced. We didn't have the technology. By the early 19th century, German astronomer Wilhelm Obers said, "Dark night. It's because there's a dust curtain blocking most of the starlight." But then I found out that's not right either. Stars don't just shine. It also releases super energy. It heats up the dust until it glows. If there is a dust curtain, the night is still bright. But here's the thing. Every day as soon as the sun sets, the sky turns dark. So what's wrong with these theories? Digges Obos, these old scientists all think the universe is infinite. But modern astronomy has long since disproved this claim. Stars look more, not enough to light up the night sky, because neither the stars nor the universe itself is immortal. They're both finite. The universe has its own boundaries. It's not as old as scientists used to think. For humans, 14 billion years is long enough. But on a cosmic scale, it's just adulthood. The most distant stars, their light hasn't had time to fly to Earth yet. In other words, with today's high-tech telescopes, we got it. The farthest starlight takes billions of years to reach Earth. This means, when you look up at the sky, what you see is actually the stars of the past. The current telescope captures the light that set off 10 billion years ago. Telescope you knew. The longer the history of the universe we can travel back. Maybe later, we can study the black gaps between stars. What about the universe before stars were born? But let's put this aside. Let's talk about the stars. Okay, now I know. The stars don't light up the night sky. It's because they're not just old. It's still far from us. Here comes another problem. Why are the stars closest to the Earth not as bright as the sun? There must be thousands of stars in the universe, much closer than those on the edge of the universe. There is, let's say, our solar system's nearest neighbor, Proxima Centauri, just over 4 light years away, like a backyard neighbor. But guess what? Without binoculars, you can't see it at all. It's too small, only 1/7 the size of the sun. It's a few thousandths of the brightness of the sun, and that's for light years away. It's actually about 38 trillion kilometers. In comparison, the sun is only about 150 million kilometers from the Earth, hundreds of times worse. So the sun is near and big. Other stars are brighter than the sun. It's so far away. Can't those distant stars bring some light to the Earth? For example, it's like you turned on a bunch of little halogen lamps, compared to a large LED light, although it also shines. But the brightness is not on the same level at all. That's how far away the stars are. Yes, but it's so weak you can barely see it. And space isn't completely empty. There's a lot of gas in there. And these gases are going to be floating around, gathering into clouds, like a curtain blocking the light of the Milky Way. So we can't see the whole picture of the Milky Way with the naked eye. You need specialized equipment. But Obos was half right. It's just that it's not dust that blocks the light, it's gas. So what does the Big Bang have to do with this? According to the Big Bang Theory, the universe exploded 13.8 billion years ago. Since then, everything is flying around. The universe is expanding. The distances between celestial bodies are getting farther and farther. Glowing celestial bodies are also floating. The high beam is scattered, so space is getting darker. There are more and more dark places. They've been floating for billions of years. Our telescopes can't tell they're moving. So how do scientists know that there are these black regions? Basically, they move by seeing things they can see. A planet goes around a star, an attractive force between celestial bodies. These phenomena, it can only be explained by the existence of invisible celestial bodies. Scientists say most of the matter in the universe is invisible. It's black in our eyes. So what do these dark regions look like with a telescope? That would be beautiful. The dark areas will turn into rainbow lights. We can't see it with the naked eye. It's because we can only see visible light, and the electromagnetic spectrum is simply the family of light. Visible light is just a small part of it, and radio waves, microwaves, invisible light. These invisible lights are actually all over space. Now the telescope can catch them, and you'll see these dark-looking nebulae. It will emit various colors of red, blue, purple, and yellow. What color is it? It all depends on what gas is in the nebula. If you really had these glasses, do you think the universe will shine for you? Tell me in the comment area.